Hi, good afternoon, everyone. The session will start in a few minutes. Thanks a lot, everybody, whoever joining now onto the session. So we should be exactly starting at 3 o'clock, maybe 1 or 2 minutes here and there. Thank you very much, everyone. Looking forward to an amazing session. Hi, good afternoon, everyone. Thanks a lot for joining in. Should be starting a session in a few minutes, so kindly be on the meeting. Hi, everyone. Very good evening to all of you. Thanks a lot for joining in for the session. It's quite overwhelming to see so many people joining the classes, but as in Zoom, we can only allow maximum of 100 participants with the bandwidth what we have today. For rest of all the participants have to watch the same session on YouTube Live, where we have unlimited number of people who can watch the session. All right. So if any of your friends are still waiting in the line, so please inform them to join the session on the YouTube. So I'll also drop an email to everyone that you guys can also inform your friends that we can just about in case if anybody is missing out to join. Yeah. So cool. We should be starting the session in a few minutes. We have Krishna, who is a senior simulation engineer, who is joining the session in a minute. So we request you to be online and also to make part in this session. So you would require a laptop. And also an Excel software. So I request you to have all of that ready. And yeah, somebody asked me for an YouTube URL. So guys, I think I have, yeah, I'll send you the channel link so that you can send it to your friends. Just give it a second here. I'm just streaming that come happen here. 1 second. Cool. Right, so just sending a text message to here to everyone. Okay. So Krishna, hi. Are you there? Can you hear us?
Yes, Suraj.
Fantastic. Sounds great. Krishna, we should be starting in a minute because there are a lot of participants who are waiting because our maximum capacity in Zoom is only 100. So I'm just sending an email to everyone. Just give me a minute here for the rest of the participants. They can, join on our YouTube channel. You can just check with all the participants if they have the computers and things ready, that they can start ahead with things like calculations and all. So we just can set the discussions.
Yeah. People, like, you can just open your Lappy or like Excel sheet. Just be ready with the software. Like after after 20 minutes, like we'll be dealing with the Excel sheet only, like all calculation and everything. Okay. Initially, like we'll go through some equations and everything, and also try to take down the equations and the data, like with respect to which I'm trying to stress it out. Okay, you can take those all the equations. Yeah, I hope it is clear.
All right, Krishna, I've also sent an email to everyone that they can join also on our YouTube channel. So let's just take some more seconds here before we begin the session, because people would be having difficulty to join on Zoom, so that they can join on YouTube.
Yeah,
so,
I get it.
Perfect. All right. So great. By the way, good afternoon, everyone. Thanks a lot, everybody, for joining in. And we have received a fantastic, interest from 1,480 people. We were planning to conduct not for this many number of participants. So because there were so many people who are interested to learn these things, we just have to open up the portal for many people, and we would ensure definitely everything was practical and hands-on as it is promised. So I believe time doesn't matter, because there are many people, there will be more questions, and that means it may take more time for us to interact with everyone to address everybody's question. So it's always a Decibels way. We ensure the quality, we ensure to teach something that is valuable, not to just get away to teach you things and this is called as a workshop. This is going to be a super awesome hands-on program that you would definitely enjoy during this session today. Krishna, so just in case, ask any of the nearby colleague to also open up a YouTube channel and see the questions over there too. There are participants who are attending on YouTube. on our channel. So we have about 60 plus participants on YouTube. So yeah, if in case anybody have questions, so from there too, so kindly do address. So hi everybody who is on YouTube. Maybe we just have a time difference of a minute, not more than a minute, I'm sure, between what is going on Zoom and what is going on YouTube. So by the way, again, welcome all of you also who are on YouTube. So thanks a lot for joining in. So the whole intention of this session would be quite simple. That in industry, people use tools like MATLAB, Ricardo, and various other different tools to do simulations, to do a motor sizing and battery sizing. And before the simulation tools existed, we've also people used to use tools like Excel software and things like that to do calculations, because you can do scripting in some cases in Excel, and also you can include equations and things like that. So it's not anymore an industry practice to do it, but yeah, you could consider it as one of the approach of making calculations using Excel. But the complexity is, if you go to a higher complexity of a model, it becomes highly difficult to handle the calculations using an Excel sheet. It becomes quite tedious that you could do a hand calculations or in Excel-based calculations. We definitely need tools like MATLAB because there are so many test cases and documentation requirements, and also we do everything with respect to mill and then sill and hill. So all these are an integration in place. So Excel is a go-to tool for somebody who's beginning into it to understand the concepts of it. All right, but it's also been an industry practice long back, over like 15-20 years back, when also somebody could not afford to buy a MATLAB license. People have done things in tools like this. So we have an extensive course that in-depth covers on using MATLAB, where you can build a simulation, a complete model. Right now, in that we'll be only covering up to a motor sizing. All right. So because going to battery sizing and all these things is a more complex with SOC estimations and things like that. So we'll be doing it till the part of our motor sizing and things like that. So the importance of this course is pretty straightforward. That if anyone in the industry, if anyone want to build an electric bike, electric car, truck, bus, or anything, they have to size the motor, right? The meaning of sizing a motor is what should be its torque. When you talk about a torque, it's nominal torque and a peak torque. What should be its RPM? When you go to a higher level, what is its operating points? Studying those operating points with respect to various different transmission gear ratios, studying the operating point with respect to various different loading conditions, various different road profiles, trying to estimate the average efficiency of the motor at a given point of time with respect to various different conditions. So, and also think about evaluation of capture of regenerative energy, and also planning your algorithms to write a control for defined amount of regenerative energies. A lot of these things which we do as to estimate using modeling. It's a very large chunk of it. So which we take about at least 150 hours of efforts just to think about motor sizing, again on battery sizing and other components as well. So for a two-wheeler market, we take about 600 hours to 800 hours, and for a four-wheeler market, it's about 1,200 hours of efforts, which we take up in component sizing and optimization. So right now, what we're trying to deal is a portion of it at a very beginning step of component sizing. And we have Krishna here, who's a senior simulation engineer. Welcome, Krishna. Thanks a lot for joining in, and thanks a lot for your efforts to create that go-to tool like Excel, where everybody can just quickly go and learn about it. And I'm sure you're gonna deliver a fantastic session. And over to you, and take ahead the session and make the participants enjoy the session ahead from here on. Thank you very much.
Thank you, Suraj, for the introduction. Yeah. Okay. Guys, I will just consider you are just ready with your Excel sheet. After 20 minutes, we'll start dealing with Excel sheet. Okay. Initially, we'll just go with some theory part, where I will just go as an overview of all the equations. And then we'll directly jump into the calculations. Okay. Yeah. So I'll just go to the next slide. So we'll directly jump to the session. Okay. Yeah. So about the today session agenda, like we can see through that. Like we'll discuss about the drive cycle. Here, let me show. Yeah, we'll discuss about the drive cycle and approach for component sizing. Component sizing means like motor sizing, battery sizing, kind of stuff. And in order to do these all the component sizing, right, there are some requirements. Okay, so we'll deal with the resistive forces, where we'll overcome the longitudinal like vehicle dynamics part, and then we'll move to some part in the transmission system and motor, like we will dealing with, and a bit of in the battery system. And finally, we will do with the Excel based modeling. Okay, where we will calculate the motor torque, motor speed, motor power, battery power, such things. Okay. Yeah. Okay, we'll just start with the next thing. So here, like drive cycle, right? Here, if you just want to say in a simple definition, like what is drive cycle, it's nothing but the velocity upon time graph. Like if you want to know more on the things, right, like how and how it is formed, like what is exactly the drive cycle and such thing. Okay, it will include all your road conditions, such that like if you are just moving in the road, like you will encounter with the bumps over the road, humps. Okay, and uh, and also like traffics, the pedestrians who is passing over the road. Okay, like just moving across the road. Yeah, these will all considered. Say like how if you want to consider the drive cycle, right, just consider as a point A, like if you're if you're planning to go from your house to the market. Okay, just consider this point. I'll just show. Yeah, just consider this point as A, where you are start with the vehicle, and there you will move with the to some place, a destiny like market or anything, or to your school or anything like colleges. Okay, yeah. So while you are driving or riding your vehicle from point A to the point B, uh, like you will be increasing your velocity of the vehicle, or like you again you will be decreasing of speed of your vehicle or velocity. And due to some traffic, you may like uh, stand still with your vehicle, and then again after the clearance of the traffic, like you will just again you will accelerate such kind of things, right? When you deal with the humps in the road, and again you will slow down your vehicle. So these all are considered like like these all will come in as a counter while you are going from destiny A to the destiny B. Okay, so these will all the kind of characteristics will overcome in the drive cycle. If you want to say in a simple words, it's nothing but the velocity and the velocity upon time graph versus time graph. Yeah. This is drive cycle. Okay, this is which we have considered here as a NEDC drive cycle. It's a new European drive cycle, where it represents some part like of the European road condition. Okay, of the particular country. We have also Indian drive cycles and other countries drive cycles. Those drive cycle like they represents their country road conditions, or kind of behavior you can call it. Okay, yeah. So if you have any thing to say about the drive cycle, like if you understood the drive cycle, like what exactly it means, you can just type yes in the chat box, like so that I can move ahead. Okay, yeah. So here we'll deal with the like how the approach of motor sizing and the battery sizing we'll discuss. Okay, I'll just start. In order to do like motor sizing and the battery sizing, right? We require like we initially we like dealt with the drive cycle, like how we can make use of drive cycle in order to do the motor sizing and the battery sizing. So here we know drive cycle, like it represents the velocity upon time graph. Okay, like with different at the time thing, you will be having the different variable velocities. So with these things, like we are going to calculate all the longitudinal dynamics of the particular vehicle, which we will be dealing in the vehicle dynamics part. There, after calculating all the related resistive forces and everything, we will calculate the wheel torque and the wheel speed. And then with the wheel torque and the wheel speed, by having the known data of related transmission system, we'll calculate the motor torque and motor speed. Okay, and then at the motor, like we'll calculate the motor power and the battery power. So yeah, this is how the approach we are going to follow. Like when we are doing with the calculation, you'll get more idea like about the approach. Yeah. Yeah, I'll just move with the next slide. So I'll just try to clear the drawings. Yeah. Okay. Here, resistive forces. What are resistive forces, like which will be acting over the vehicle when it's moving? Okay. When it's in the like stationary or like in the moving. Okay. You can just say like aerodynamic force, gradient force, and the other forces like rolling force and acceleration force. Acceleration force will be the thrust force, which is for the forward movement of the vehicle. These forces will be acting like aerodynamic force, gradient force, and rolling force against the motion of the vehicle. If vehicle, just consider if vehicle is moving in this direction, right? All these forces acting against the vehicle movement. Yeah. So how the aerodynamic force like will affect what exactly the aerodynamic force, right? We'll just discuss on this thing. If you just consider this vehicle, it's in a side view. If you just try to imagine it's a front view of this vehicle, I just try to write here in the square format. Okay, yeah, it will be like just consider in the square format. Yeah, for the reference thing. So this is the frontal part of the vehicle. Just if you just imagine from the other side of the vehicle, you will just get that this is the frontal side. So it is completely exposed to the air. Like whichever your direction, at what direction you're moving, right? At that direction, you will getting the opposite like air kind of thing. You will be exposed to the air. That will exert a force on your vehicle at the frontal part of the body. So that whatever the force is exerted, right, on the vehicle here. If you can just see here, I'm just trying to make, let me clear the diagrams. Yeah. Whatever the force is going to exert on the vehicle, it's going to add some negative, it will be in the negative, like a resistance for the vehicle movement. Okay, that in order to calculate this aerodynamic force, we are going to deal with this equation. So what exactly the equation is that, here if you just see here, like aerodynamic force equal to half into rho into frontal area and coefficient of the drag and v square. V square means velocity. Okay, just try to take down the equations because while you are doing in the calculation in the Excel sheet, right, you need these equations. Okay. Yeah. So we'll use this equation in order to calculate the aerodynamic force. If you want to know like more about the equations, like what is CD and what is like how it's calculated, and how the air density and aerodynamic like frontal area is going to affect, like there is another course in the YouTube under the Decibels Lab channel. There you can see, okay, about the complete how the equation is arrived, such things, and all the components in a very deeper meaning. Yeah. Now we'll move to the next force, that is gradient force. Yeah. Here, how it's going to affect on the vehicle is that, like whenever there is an inclination over the road, like there is a, when it's moving along with the inclination over the road, right? If you just consider this road has an angle, it will be in the theta. Okay, the inclination, whatever you measure, it will be in the theta, has an angle. Just if you consider, as the vehicle moves over like while up hill, climbing up the hill, so it's going to have a one like downwards force as a component force. You can just consider against the vehicle direction. Okay, you can just consider this as the gradient force, which will be against the vehicle direction. If the vehicle direction is in this way, the downward force will be in this way. Okay, that it will be including the weight with respect to the total, the weight of the vehicle with respect to the inclination angle. Yeah. In order to calculate this grade force, right, you will be dealing with this equation. See, GVW, this means gross vehicle weight. Here, gross vehicle weight, here I'll just try to tell, like gross vehicle weight equal to mass of the vehicle. Okay, just make it clear, it's a mass of the vehicle, and driver mass. Yeah, you are going to add both these masses, and like it is gross vehicle mass. Okay, sorry, yeah, it's a gross vehicle mass where it will include both driver mass and the vehicle mass, and then you are multiplying GVM, gross vehicle mass, into acceleration due to gravity, G. So you will get the gross vehicle weight. Okay, so this gross vehicle weight you are going to multiply with this whatever the inclination, the angle, that is theta. There you will get the gradient force. Yeah. just try to take down the equations, both these equations. Okay, once you're done with this, taking down the equation, just type yes in the chat box, like so that I can move ahead. Yeah. So next, some again, the forces are like resistive forces, the rolling force, and the acceleration force, like it will be like a thrust force. Okay. See, whenever like the rolling force, it's in the wheel, like will be in the contact with the surface. So because of the contact, there will be a friction produced over here. That friction will be in the against direction of the vehicle movement. Just consider if your vehicle moving with this direction, like the friction, like it will be produced between the road, the surface or the road surface and the wheel. That will like produce a negative force over the vehicle movement, like it's against the vehicle. Okay, that's also going to act as a rolling force. So how it's going to be calculated, right? The total gross vehicle weight, like we know like what is gross vehicle weight, gross vehicle mass, which is of like driver mass plus vehicle mass is equal to gross vehicle mass, and it is multiplied with the gravitational force, so that it is gross vehicle weight. You are going to multiply with the rolling coefficient. Here different roads having the different rolling coefficient. We'll just consider like a general rolling coefficient, which is defined by some standards. Okay, 0.015. Okay, so if you are multiplying rolling coefficient with the gross vehicle weight, sorry, 0.015. Okay. Anyhow, like we'll get to know at the end. We have some set of data. With this, we are going to calculate the rolling force. And then the acceleration force, like how it's going to act, right? Like it is for the acceleration, like it's going to add a force, like in order to move the vehicle, which is in the vehicle direction. If you want to move in the vehicle, right, it will be in the same direction. So we'll also include this acceleration force for to do the component sizing. Okay, it's, you can just consider it as a thrust force. Acceleration force, like you can calculate with using the gross vehicle mass into the acceleration. Okay, just try to take down the equations. Once you're done with taking down the equation, just type yes in the chat box. Okay, yeah. So you have calculated, like we know the equations in order to calculate all the resistive forces. Here the aerodynamic force, gradient force, rolling force, acceleration force. Okay. Yeah, once we know like all the forces, we are going to add all the forces. This AF, like it's a aerodynamic force, and this is rolling force, gradient force, and acceleration force. Okay, so you're going to add all the forces, and then you will get the total tractive force at the wheel side. like this much of tractive force is required in order to overcome the resistance and for to move like overcome the resistance and for also for the movement of the vehicle. Okay, this much of force is required at the wheel side. And then with knowing all these tractive forces, right, for total tractive force will come, we can calculate the wheel torque and the wheel speed. So for to calculate the wheel torque, we require the total tractive force. Okay. We are just going to multiply the total tractive force with the wheel radius, which will be the given value. Okay. Once we know the wheel torque, further we'll calculate the wheel speed. See, we know the velocity of the vehicle, so we are going to calculate the wheel speed, which will be in terms of RPM by using this equation. Once we calculate this wheel torque and wheel speed, we can calculate the motor torque and motor speed with knowing the values of transmission systems, like the gear ratios, transmission efficiency. Okay. Yeah, I'll just try to show you. Let me clear. Okay. Here motor torque equal to wheel torque divided by gear ratio. GR means gear ratio. Okay. And you are going to divide it by transmission efficiency. It's because like whenever you are the torque from the motor to the wheel you are supplying, right, like when it's passing through, there will be some losses, as there will be has a power loss. Okay, so this is transmission efficiency. You are just going to divide the wheel torque by the gear ratio and the transmission efficiency, you will get the motor torque. And then to calculate the motor speed and that is RPM of the motor, you are going to multiply the wheel speed, which we have calculated here. Like we are going to multiply wheel speed with the gear ratio, which is given value. Okay, we'll calculate the motor speed. Now just try to take down all the equations. If you just done with the taking down the equations, you can just type yes in the chat box. TEFF means it's a transmission efficiency. G dot R, like it means GR means gear ratio. Here, if you just consider tractive force, like AF means aerodynamic force, rolling force, gradient force, and acceleration force. Yeah. So I'll just try to move to the next slide. So in order to calculate the battery power, right? So we are like, so before that, like we need to calculate the motor power. Okay. Here, in order to calculate the motor power, we can use the basic equation, that is 2 pi nt upon 60, P equal to 2 pi nt upon 60. Please explain what actually is the tractive force. Okay. V is for velocity. Yes, V is for velocity. Wheel torque is for all the wheels. Please explain what is X. Okay, I'll just try to explain. I'll just go to the slide. Wait, yeah. Here, the tractive force is like a total force which will be acting over the vehicle. See, initially, like we just discussed about the aerodynamic force, how it's going to act against the vehicle movement. Okay, and rolling resistance, like it's because of like whatever the friction is created between the wheel and the surface. That's also going to like add some resistance for the vehicle movement. And gradient force. Okay, it's because of when you are up going like hill climbing or just downhill climbing, it's going to add whatever the gradient force. So for all these, this is like totally for the you can just consider it as a positive force. For to do the component setting, we need to add all these forces like total tractive force. I hope you got it right. Yeah, Krishna Kumar. Okay, I'll just try to explain this thing. Here, you just consider a block here. I'll just take a small example. So here, in order to move this block, just consider this block, you need a 15 Newton. Okay, there will be like forces will be acting like friction, like the rolling force or like aerodynamic force will be acting over this block. In order to overcome these resistance, you need 50 Newton. If you apply the 15 Newton here, right, like both side will be get cancelled and it will be like balanced. Like you just overcome the resistance forces, but the vehicle it won't be moving. Okay. If you add like acceleration force, like as per the velocity, how it's going to vary. So for that, you have to design the battery and motor size. Okay, I hope you got it. Yeah. Wheel torque is for all the wheels. Yeah, you can just consider. You can just type in the chat box, like if you have any doubts or questions with respect to the equation or any concept. Okay, if you want to know more about these, like the derivation and everything about the equations, there are some other free courses which are in the Decibels. Okay. Yeah, you can just consider like it's not of friction, like a resistance, like it will be varying like as the vehicle move, right. It also depends like based on the pressure of the tire. Wheel torque will be same for wheels. If so, then no. We have considered like total weight of the vehicle. I hope you got it right. I just tried to show here, like here in order to know the rolling force, right? Total, it depends on like total weight over the wheels. And here the total like frontal part of the vehicle. And for the gradient, like total weight, again we are considering with gross vehicle weight. So we don't need to multiply with the four wheels. I hope you got it right, Kishore Anand. See, transmission efficiency, like we'll be including in the torque. Okay, that is the different parameter. Okay, sir. Yeah. Okay. If you are done with this thing, you can just type yes, or you can just ask some more questions. Like I can wait and deal with the questions. Okay. Okay. I'll just go here, like where we stopped at the earlier. So here, like we need to do just missed here, motor efficiency. You can just consider. You can just consider here to calculate the motor power 2 pi nt upon 60 into motor efficiency. Here, like we have included for the motor torque, the transmission efficiency. Okay. As like efficiency, like whenever you are supplying like power, like I'll just explain like in the further. Okay. Here. Yeah. This will be the equation we use for the motor power to calculate the motor power. Okay. MS is motor speed and the motor torque, MT is. And to calculate the battery power, we'll be using like motor power divided by motor controller efficiency. I will explain this one, like how it's going to be. If you just consider this as a battery and this has motor, okay, this is motor, this is battery, and this is motor controller. So you are transferring, like you are transferring the power. The power flow will be in this direction, right? So, like whatever the source, the power which we are giving from the source, just consider like 100 watt. Okay, there will be some losses while passing through the motor controller. Okay, there we are going to have some 10% of loss. So at the motor, we will be getting about 90 watt. So if you know the losses, like how much watt losses like we are getting, right? So with this we can calculate the battery power. Yeah. I hope like if you have taken up to here the equations and everything, just type yes in the chat box. If you have any doubts, you can just still ask me. No, here the motor controller, like it is used for to control the speed, the power supply, the current supply to the motor. Okay, even it will help to help you in the like in the region. We know like what is the region, right? Regenerative energy, whatever the regenerative energy is produced, right? Okay, whatever the regenerative energy is produced, like how much regen energy we can utilize and sent to the battery for the charging. That is also controlled by the motor controller. Oh, okay. What is GR in the previous slide? Here GR is gear ratio. And what is the reason for power loss in motor controller? Okay, I'll just try to explain. Here motor controller, if you know, like afterwards you can just try to Google like what, just type in the Google like what is motor controller. Uh, it will be having some capacitors components like MOSFETs, resistance components, or it is some kind of like it will be built with the PCB design. So like same as you see in your laptop or anything of the PCB design. So it will be having some like capacitor, resistors, and components, such things, MOSFETs. Whenever they will be working, right, they are going to emit out the heat. That whatever the heat loss is there, right, we'll consider it as a energy loss, heat energy loss. So as they are going to get like whatever the MOSFETs and whatever the components, they are getting heat, right? They are while in the high temperature, the efficiency of their working, trying to which like the good performance which they have to give like in the earlier temperatures, they won't give. Like it's like it lots is like because of the high temperature, the efficiency of this motor controller will be decreased. Because of that, like uh, there will be some losses. Yeah, Kishore Anand, yeah, it's gear ratio. Gear ratio. I hope you got it right. Shubham Kumar for power loss in the motor controller. For Rajat, yeah, we need to divide with the motor efficiency. See, we are going in the reverse order. The first thing we need to remember that, like we are going in the reverse order. We are coming from wheel and then transmission system and to the motor and to the battery. Okay, you are here. We are going to divide with the motor efficiency. Okay, yeah. I hope it's clear, right, Rajat? Yeah, I'll just try to clear all the diagrams. So if you just taken down the equations, right, just type yes in the chat box. Okay, we'll just move to the next slide. Yeah, like it is defined. Okay, it is defined for some. If you just consider two-wheeler, right, like the maximum inclination angle can be of 7.8 something is there for two-wheelers. For different vehicle, like it's will be different. It is which is given by the government or central government. Like it become a standard, and it also depends on the different countries. Means like 7.8 degree and such things, that has to overcome, the vehicle has to overcome such grades. Okay, just try to take these parameters. Like we will be using in our calculations. Here grade we have considered as the 0 for the present, like as per the reference, like for the time being. Okay. We have just considered like road is completely flat. So just try to take all the values, rolling coefficient, vehicle mass, driver mass, acceleration due to gravity, whatever their respective value. Air density, area, drag coefficient, radius of wheel, gear ratios, transmission efficiency, and motor efficiency, GVM and GVW, motor controller efficiency. Okay, if we just taken down, just type yes in the chat box, or like we can wait for 2 more minutes or some minutes. Yeah, GVM is gross vehicle mass. GVW is gross vehicle weight. Yeah. Okay. I just tried to explain. So we know the basic thing, right? How you're going to calculate, like if you just consider you are sending a like you are just inputting the power here, and there will be the output power. Okay. So if you want to know like how much output power, like power loss, like it will be defined in terms of like uh, percentage or anything. So if you know like you are giving input as 100 watt, and at the output you are getting like 90 watt, right? Just try to divide like output power divided by input. Okay, we are using this equation. So here why we are dividing it by motor efficiency, right? This part will give you motor power. Okay. If you just consider this as a motor, right? You are going, this is input side and this is output side. Input and out. Okay. Yeah. So you have calculated the output power. This part, whatever you're getting, right? 2 pi nt upon 60 will help you to calculate the output power of the motor. So if you know like what is its efficiency, we can calculate the input power just by using this.
I think, hey, time moves a little quicker. So I think we can take the questions at the last. So it will be quite wiser.
Yeah.
To follow up the class and then take the questions at the very
Okay.
end. Yeah.
Okay, sir. Yeah. Okay, I'll just take this last one and I'll just move with the calculation part. Yeah, I hope you got it right. Okay. If you are done with this thing, right, I will just try to move to the like Excel sheet. Just be ready with the software. Yeah, just try to open the thing. Okay, so we will like give you the link of this drive cycle. Okay, let's not worry about this one. But still, you can just do the calculation along with me. Like later, we'll get to know. So if you have taken the data right of the vehicle, we can assign here that respective data. I'll just try to initialize the data. Okay, vehicle parameters. And values. Just try to do along with me. Okay. First one, like we'll mention like vehicle mass. I'll just name it as vehicle mass. It is 111 kg, 111 kg. Okay. And then mass of the driver. That is driver mass. We'll just consider 80. Okay. And then rolling coefficient. Yeah, just name it as a short in a shortcut. Okay. That is 0.015. And then grade, which we are in like considering it as a 0. And then frontal area of the given vehicle. That is either 450x. So its frontal area is 0.875. Here area will be in the meter square degree, and mass will be in the kgs. Okay. I'll just try to initialize the units also. It's fine. And then air density. We'll just take air density as 1.225. Like kg per meter cube. Okay. And radius of the wheel of ether. I'll just name it as radius of wheel. It is 0.1524. And gear ratio. Here gear ratio, we can take it as like 7.8. It is a given by the company itself, like of the ether. Transmission efficiency. These efficiency, actually it will be varying, but here we can consider it as a constant value. Like they will be varying with respect to different torque value and the RPM values. Okay, the speed and the torque, they will depend. Okay, yeah. Efficiency, I'll just take it as 0.85. And motor efficiency. Motor efficiency 0.9. and like we'll calculate GVM. GVM means, I'll just try to mention it capital. Gross vehicle mass. We know like gross vehicle mass is vehicle mass plus driver mass. Just try to see here. I'm going to assign an equal sign here. Then I'm going to select B2, that is vehicle mass, and I'm going to add a plus symbol and then driver mass, and then say enter. Okay, you'll get the gross vehicle mass, and then gross vehicle weight. So before assigning the gross vehicle weight, we'll assign the acceleration due to gravity value G equal to 9.81 meter per second, meter per second square. And then we will assign motor controller efficiency. So before that, we'll assign GVW, that is gross vehicle weight. So that is gross vehicle mass is multiplied with 9.81. I'll just try to assign equal sign, and then I'll select GVM multiplied with with 9.81, and then say enter. Okay. Yeah, Vinit, I'll just try to. I hope it's clear, right? Like of the zooming the screen. I hope you can see now. Yeah. It's acceleration due to gravity value. Okay. It is required like while we are dealing with the grade thing. Okay. Yeah. Now I will assign motor controller efficiency. It is 0.85. Yeah. So here, like we have initialized all the parameters which is required for our calculations. Okay. Now we need a drive cycle for it. GVM. Okay. Here for the GVM, like you have to assign, start with the equal sign and then select B2 and then B3. Like after selecting B2, add a plus symbol and then B3 and then say enter. Okay, you will get like GVM value. We just adding out the vehicle mass and driver mass. Yeah. So we have initialized the vehicle parameters. Now we will initialize our drive cycle, which is velocity upon time graph. Here also we have taken NEDC drive cycle. Like, yeah, I'll just try to show. I have to just select the whole thing. I have to drag up to here, copy. Like we will give this drive cycle. Okay. Let's not worry about now. Yeah, I have just taken the drive cycle here. I will just try to plot this graph. So we already seen like this drive cycle, NEDC drive cycle, which represent the European country road behavior. Okay, I'll just try to delete it. Yeah. First, we'll convert like presently the velocity is in kilometer per hour. So we'll convert into meter per second. So I'll just try to show you velocity in meter per second. Yeah. So for that, we have a conversion factor, that is we need to multiply the velocity, this one, into bracket 1000 divided by 3600 and close bracket. I have selected the E2 here after assigning the equal sign in the velocity in order to convert into meter per second, and then say enter. Okay, because as the velocity is 0, right, it will obviously show the 0 here. If you want, if you just select here, right, you will also see the equation here, what I have assigned here. Okay, let me clear. Yeah. 1000 divided by 3600. Yeah. Now just select this one and drag till last values. You will just get to know, like, yeah. So I'll just try to show. This drive cycle, like, we'll give a link in the at the end of the session, like to the YouTube channel. There you can just download this one. The meanwhile, you can just assign all the equations and everything. Later, just adding the drive cycle, you will get to know. Yeah. Now, like, whatever the values are there here, right? They are in the meter per second. Like with respect to each row value, they are converted. Okay. Now, I'll just try to calculate the wheel speed. Wheel speed, which will be in the RPM. So we know the equation, right? Wheel speed equal to, I'll just try to write here also the equation. Like, I know, like, I'll just consider you have taken down the equation. Still, I'll just try to write here. This is pi, okay? And you're multiplying with radius of wheel. This is radius of wheel, RW. Okay, this equation you are going to assign it here. I'll just try to equal sign. V will just consider this velocity, and I'm just trying to use the multiplication sign and multiply with the 60. And then we'll divide with this 2 pi into RW. Yeah. Okay. Just try to say it once again. See, like, in order to calculate the velocity, we are just converting the velocity in kilometer per hour to meter per second. We are just using this conversion factor, that is, like, in order to convert into meter per second, like, you are just going to multiply the velocity with 1000 and afterwards you are dividing it with by 3600. Here, like 1 kilometer equal to 1000 meter and 1 hour equal to 3600 second. I hope you got it right. Velocity column. So these data will be given. Okay. Once you assign value at the first value, you just need to drag from here with this point, dotted point, till the end of the drive cycle. I'll just try to show the same procedure here with this assigning the equation. G2 is multiplied with 60. Now divide with 2 pi RW, 2 multiply. Pi value is 3.142, and then R value like RW, that is radius of the wheel. Here it is the radius of the wheel, right? If you just try to see, this one is the radius of wheel. I'll just try to assign and I will explain like what I'm trying to use here. I'll just try to select this radius of wheel, and then like for this, I'll just try to use dollar symbol. I'll just try to explain like why I'm using. So here, like radius of wheel will be considered as a constant value. Okay. Here the G2, that is velocity, will be varying, right? So as we like drag the column, like it will also, like if you don't mention the dollar symbol, it will also go on considering all the respective values, like in this way. Like for in the next thing, it will consider 7.8.85. So here I want only the constant, only this particular value has to be repeated along the whole entire column for the calculation. So for that purpose, I'm using the dollar symbol here. Okay. Yeah. Now say enter. Now I will just try to drag till to the end of the drive cycle. Sorry. Yeah. It's not an and symbol, it's a drag dollar symbol. Let me see. No, it's a dollar symbol. You can just see here. I have mentioned the dollar symbol. Yeah. So next, we'll calculate the resistive forces. Okay. First, we will calculate with aerodynamic force. We know the equation, right? Like for the aerodynamic force, I'll just try to write here 0.5 rho, and then frontal area CD, that is coefficient of drag, and then V square. Okay, this equation, like it will calculate the aerodynamic force. We'll just try to assign this equation here. Okay. Yeah. Equal to 0.5 and I'm going to multiply with next rho. Here rho, air density. Rho means air density. Okay, we know the air density value, so I'll just try to select this one. So again, I need to add dollar symbol, because for the entire calculation I need it as a constant value. And then I'm going to select frontal area. We know the area of the vehicle, frontal area, which is given here, 0.875. I'm going to select that one. Sorry. Yeah. I'll just try to and multiplication symbol and then select area. Again, I need to add a dollar symbol here. Now I will multiply with the CD value, that is, which is given. Okay. Maybe like we haven't mentioned the CD value. Yeah, it's 0.22. I'll just try to assign this one. Okay, let it be. Let me clear this one. Just try to take down the value. Coefficient of drag. Just okay. It's 0.22. Yeah. Again, we'll just try to assign the equation. 0.5 multiplied with air density. We'll add a dollar symbol there. Before B and like in between B and 7. Okay. And then we'll multiply the area which is given. Dollar symbol. And then okay, again I will use the multiplication sign and I will try to include coefficient of drag. Again, dollar symbol is required. Now, yeah. So it is a standard thing, like means it has to be constant. Here, whatever the dollar symbol you are trying to add, right? It will try to maintain at that particular row and column for the entire calculations. For that purpose, we are adding dollar symbol. Just check with adding only dollar symbol to the B, and then try to do, like you can get like what I'm trying to say. Now, in order to do like we know the equation, right? V square. So to assign the V square, there is some code kind of thing like power bracket velocity value, that is G2, and then comma and 2. Here it is nothing but it's a V square, velocity square. Here whatever the exponential term you can just mention, like if it's V3 V raised to 3, you can just type 3. Here we required V2, like V raised to 2, so just we are just mentioning the 2 value. Okay, yeah. Now say enter. Or also you can just the other method, like you can just mention the velocity term like 2 times, just multiply V into V. Okay, Yeah, I'll just say enter. Okay, just 1 plus 1. Let me check. I should not mention this one. Yeah, because of some dot value we have mentioned, it was showing some error. Yeah, now I'll just try to drag the entire thing to the last value. Yeah. Yeah, just in order to consider it as a constant for our calculations. Now we have done with the aerodynamic force calculation. Now we'll calculate rolling resistance, rolling force. For that, we know the equation, right? GVW into coefficient of rolling resistance. We'll just try to assign, like write the equation. GVM. Sorry, GVW. I'll just try to clear. GVW into CR. This is coefficient of rolling resistance. Okay, the value is 0.015, and we know the value. Here it is. Okay, we'll just try to assign this equation here. We'll select GVW. For that, we need to assign the dollar symbol here. Sorry, yeah, and then multiply with the rolling coefficient, coefficient of rolling resistance. Again, for this, we need to add a dollar symbol. Yeah, then say enter. It will be constant, the rolling force, because it's doesn't depend on the velocity, right? Just try to drag. Okay. Now we'll calculate grade resistance, grade force. Actually, it's okay, like it's not included, but still like we have considered the grade as 0, so it's, but we'll still mention it. Okay, yeah. We know the equation, right, for the grade. Like I'll just try to assign thing. GVW, gross vehicle weight, into sin theta. We know the theta value, that is 0. So we'll just try to assign the equation here. Equal to GVM, sorry, GVW, adding the dollar symbol to it. Here we are using dollar symbol like to consider it as a fixed value, to fix that value like for our calculations. If you don't use right, like it will be like varying along with the as a drag till last, right? It will be varying. So, and now multiply and try to include sign 0. Yeah, and say enter. Now I'll just try to it will be 0 along the entire column. Okay. I'll just try to clear the diagrams. Now we have calculated aerodynamic force, rolling force, grade force. It is 0. It's because of like grade angle. We have considered as a flat road along the thing. Yeah. So we'll calculate the acceleration force. So we know the equation, right? So here we need to convert this velocity into like we need to have a acceleration values, right? So we can get the acceleration values from velocities by using a small equation, like we know how it's going to be. I'll just try to explain this one. Like difference of like just consider velocity this one and this one and respect to time. Okay, just consider like G4 minus G2 divided by D4 minus D0, or you can just say 2, like divided by 2. Otherwise, like we can use derivative thing so that we can the derivative of velocity, sorry, integration of velocity, it will give as a acceleration with respect to the time. We'll just use the simple thing. Okay, I'll just try to write here. For that, we need to consider GVM. I'll just try to assign the equation here first. GVM, that is gross vehicle mass, into acceleration. So GVM, we'll just check like, yeah, is 191, this one. I'll just try to select this one and I'll assign the dollar symbol here. Okay, and now just observe the thing. I'll just try to select G2, G4 minus G2 divided by 2. Then say enter. And I will just try to drag value. Yeah. So this is the acceleration force. Here we have calculated all the forces. or like in order to get the acceleration, we know like acceleration is meter per second square. So for that we are using the simple thing, like if you just consider, I'll just try to show with some graph. Okay, if you are increasing with some velocity, right, just consider 10, 20 and 30, and the particular time has 1, 2 and 3, like, yeah. So at what acceleration, like the velocity, the rate at which, in order to find out, like we can use this thing. Just consider this 20 minus 10, oh, like just 30 minus 10, you can just consider, or it will give the same thing. Just try to clear. Okay, you will get the value of like 20 minus 2, 10 meter per second square. Yeah. Velocity and time graph value, like we'll attach a link to it. A drive cycle data, we'll attach a link to the like at the end. Okay, you can download that drive cycle. Wheel speed formula. Okay, I'll just try to show. You can just check it out here, or I'll just try to. We already like told like to note down the equations. Yeah, this is wheel speed equation. Okay, I'll just try to clear. Okay, we'll just move ahead. Yeah. Now we know all the resistive forces, right? We'll calculate the total tractive force. So total tractive force is just to add all the forces. Here aerodynamic force plus rolling force plus, sorry, now grade force plus acceleration force, and now say enter, and just try to drag till last. Yeah. So like you have like consider, like you have added all the forces and you calculated the total tractive force. So now we'll try to calculate wheel torque. We'll just finish it off. Okay. Yeah. Wheel torque. See, torque is equal to force into radius, right? We know the total tractive force, and radius of the wheel we have to consider. The radius of wheel is, I will just see, 0.1524. Okay, I'll just consider this one multiplied with 0.1524, adding dollar symbol. And now say enter. Yeah. Now, once we calculate the wheel torque, right? We know wheel speed, which we have calculated here. Just okay. And now we have calculated wheel torque. So we'll calculate see here we have calculated the wheel torque, and we'll calculate, we know torque value and the speed value, so we can calculate the motor torque and the motor speed. Okay, yeah, I'll just try to write the here motor torque. So for the motor torque, we know the equation, right? We'll just try to assign it here. Wheel torque divided by gear ratio and transmission efficiency. Okay, yeah, we are going to assign this equation here. Wheel torque, we're going to divide with now gear ratio. Gear ratio is 7.8. Just select this one and assign dollar symbol here. And then multiply with transmission efficiency, that is 0.85. For that also we need to add dollar symbol. Yeah, I'll just try to clear. Now say enter. Okay, yeah. So here we have calculated the motor torque. Now we'll calculate the motor speed. Yeah, motor speed is like wheel speed is multiplied with gear ratio. Wheel speed, which is in RPM, we're going to multiply with gear ratio. Okay, sorry. Now say enter. Let me check like what happened. Yeah. Okay. Just let me check. Yeah, here it is I2. Okay. Now dollar symbol. Just try to drag it. We'll just check. Yeah, we'll just try to initialize it from first. Okay, I'll just try to check. B9, it is gear ratio. Okay, maybe I've considered the wrong one. Equal to wheel speed multiplied with B9. That is gear ratio. Okay. Yeah. I'll just try to. Okay. Yeah. I hope it's clear now. Now we'll calculate, like we know the motor torque and the motor speed. So we'll calculate motor power. Just try to write motor power. Okay. We know the equation, right? Like the basic equation, motor power 2 pi nt upon 60. Here, this equation will give you the output motor power. Okay. If you just again divide the thing with motor efficiency, right? You will give like you will get motor input power. Okay. I'll just try to assign this equation here. Two multiplied with pi. Pi is 3.2, and then RPM. Sorry, yes, motor RPM, and then multiply with motor torque and divide with 60. Okay, and motor efficiency. Here it is a motor efficiency. I'll just try to select this one. Yeah, add a dollar symbol to it, and then complete the bracket and then say enter. Yeah. So I'll just try to clear this thing. We have calculated the motor power. Now we need to calculate the battery power, which will be the last calculation. Okay, I'll just try to assign the equation here, like naming part, battery power. Okay, could you please repeat the Excel formula for wheel torque? So you can just see the equation here. I have selected the total tractive force. I'll just try to show torque equal to force into wheel radius. Okay, this force is total tractive force and this is wheel radius. Okay. Now we'll calculate the battery power. So battery power, like we have mentioned the equation, that is battery power equal to motor power divided by efficiency, motor controller efficiency. Okay, we'll just try to assign this equation here. Yeah. We'll just try to clear. Okay, before clearing, I'll just assign the equation. So equal to sign motor power, we'll just select the motor power and divide with the motor controller efficiency. Motor controller efficiency, like it's 0.85. Okay. Now we'll just select this one and add a dollar symbol to it. Yeah, and then say enter. Yeah. Okay. So we have completed all the calculations. I'll just try to clear all the diagrams. So we'll like start comparing the graphs and we'll do a small analysis over the graphs. Okay. Like how it's going to vary with each other. So yeah, I'll just try to bring some velocity graph here. So this is velocity graph. Drive cycle. Okay. And then I will try to bring forces, that is aerodynamic force, rolling force, grade force, and acceleration force. We'll just neglect this grade force, like it will show the entirely 0 because we haven't considered the grade angle. Yeah. Let me, yeah. Okay. And then here rolling force, it will be showing entirely constant value. So even I will just try to insert the graph for it. Just keep this here. And then we'll bring acceleration graph. We'll just keep this here. Okay. We know, like, if you know the equation, right, for the aerodynamic force, like how it's going to vary and everything. Depends on the velocity, right? Force, aerodynamic force, which like the air which is exerts pressure or the force over the frontal part of the vehicle. It depends on the velocity. Like if you just see here, if the velocity is increasing at this part, it's showing some increasing part, right, compared to here. The aerodynamic force also increase. It's like directly proportional to the V, whatever the force. Okay. And then like here the rolling force, like it's completely depends on the rolling coefficient and the weight. Weight will be the constant And the only thing we can vary that rolling coefficient of rolling resistance, but here we have considered as a constant, so it's showing the constant thing. And if you consider the acceleration force, so again it will be depending on the velocity. If you just consider here, like if we know, like if velocity is constant, the acceleration will be 0. If you just we'll just consider this part. I'll just try to clear before showing. Yeah. So at this particular time, like if you just see the thing here, it's showing 0, right? The force which will be acting over the velocity at a constant velocity, like whatever the acceleration force will be acting 0. And if you are trying to like slow down, like if velocity is decreasing, the acceleration force like will be in the negative, because we are in the deceleration part. So, and if you just try to see this increasing velocity, like you can just see it will be increasing at this particular time. So this is how like it will depend on the velocities. Okay, we'll just try to clear. Now I'll try to bring some other graphs. We'll just compare with the velocities, like motor torque and motor power. Okay, we'll just repeat everything once again once I finish this thing. So I'll just try to bring motor torque here and then motor power. Like how the sizing, just repeat it. The motor sizing, how we can do, and what are the peak torques and what are the nominal torques or continuous torque. We'll just discuss, and the RPM also, in order to do the motor sizing. And I'll just try to bring motor power. So here, these are the motor torque graph, and this is motor speed. Like it will be in the RPM, and the motor power. It's in the watts. Okay. So if you just consider these things, in order to select the motor, right, based on the torque value, like from this graph you can just study, like you can just say that it will require continuously a torque of about near to like 7. If you just consider, okay, 6 to 7 torque is required in order, you can just consider it as a peak torque, like the continuous torque, not peak torque, a continuous torque. It means a minimum torque is required for the motor in order to satisfy with this particular drive cycle data. Okay. And in order to get the like peak torques, we have to do the acceleration performance. So there we will get the peak torque values. Okay, here we can just consider like that whatever the drive cycle we have considered, right? It represents some European like highways thing. So in order to drive your vehicle comfortably, like your motor torque should be continuously giving about 7 Newton per Newton meter kind of stuff. Okay. And if you just consider with the motor speed, right, like it will depend on the velocity itself. Okay. As the torque is in the like has the higher torques, like it will be showing it some lesser RPM. See, peak torque you can just get in the performance, like when you are trying to perform the vehicle, like if you are just trying to drive the vehicle for with full acceleration from 0 to 5 seconds, like in order to get the top speed. So whatever the torque, there you can get the peak torques. Here you can just consider this as a continuous torque. It means a minimum torques are required in order to select the motor for this particular drive cycle. So in the same way, they are going to insert all different countries drive cycle, and they will take an average of all the motor torque, like continuous torque, the peak torque as the average value, or like they will just go on testing with some like more than 10 of drive cycles, at near to 100 of drive cycle for all country drive cycles, and then they'll select the average motor torque of that is with respect to nominal or the peak torques. Yeah. So motor power, like here you can just notice that it requires more, right? So it is like uh, directly proportional with the torque and the speed. So whenever you're trying to go with the higher speed, like you require more power. It like it says like it shows that more power. So how much power for your motor, like it's if you want to select the power size, like power, right, for your motor, you can just consider these things. These are in watts. Okay, the whatever the values are in watts. You can, if you just a minimum thing you required here has a continuous power near to like 3 kilowatt or like 4 near 3.5. Okay, a continuous motor power. Like you will get the peak motor power at when you are doing the acceleration performance test. Okay, yeah, this is how like we'll do the motor sizing. Okay, if we consider with respect to motor speed, right, the minimum motor speed, the RPM of the motor running should be within the band of like 8,000 to 10,000. It should be there, so that it's a minimum thing continuously. It will show different for different drive cycles. Yeah, this is how we do the motor sizing. So we have explained only the motor sizing with respect to only one drive cycle. Like if you just consider in the industry, right, like they will be testing with different drive cycles, and they will consider some average values, like what are the nominal torques at all the different drive cycles. Like they will again keep on like testing with highway road conditions and the urban area conditions and rural area conditions. It will be keep on varying. Okay, yeah. Now I'll just try to bring one more graph, which is battery power. So we can just say that like we require like the battery should be having the power, like minimum power of the battery should be of like near to 4,000 watts. Okay, like a continuous requirement. Here you can just see the spikes of the battery power. It's because of like when you're moving with the high speed, right, obviously like you are going to spend more power. Here you are maintaining some constant thing, so it's also showing some constants, a minimum thing which is required. Yeah, this is how we do Actually in the battery thing, right? We are going to calculate like in the further what is SOC, and number of cells in a series, number of cells in parallel, and range calculation we can do such things, which is a further part. Yeah, I'll just explain this thing. See, whenever for that I had to bring velocity graph. Just give me a minute. Yeah. I just need to bring velocity. Yeah. And then I will compare it with the battery power. Why battery power go in negative value on motor max power, maximum speed? Okay, I'll just try to explain like why it's negative. Okay. Let me bring graph of it. Yeah. See, like we know like how the regenerative thing happens in the electrical vehicle. Like if you know, see, whenever you are like moving with a higher speed, like you are going to add some external force in order to achieve the particular desired velocity. So when you are braking, right, like again you are going to add the energy. Okay, that will be taken considered as a regen power. And if you are going down the hill, there you are not going to add energy because of the inertia, like it will be moving. There you can get the regen power again. Okay, so here the velocity is decreasing means uh, your deceleration, like you are applying phase. So at deceleration phase, the regen power will be produced. Okay, regenerative energy, which will be the negative. Like you can just consider it as a positive only, because in only the don't worry about the sign. Like just we can consider it as a magnitude. Okay, this is the like power. So whatever the negative part are there, right? These are the possible regenerative energy from this particular drive cycle. If you are using the different drive cycle, there will be the other possibilities of regenerative power. So whenever you are decreasing like speed, or you are in the deceleration phase, like you will get the negative thing, negative torques or the negative power. That is possible of regenerative power from particular drive cycle. Yeah, I hope you got it right. So this is how we can do the motor sizing. This is just a part of the powertrain. Like if you want to study more about the power in a very detailed way, so it requires a lot of efforts and it requires a lot of time to spend on these each concepts. Okay, here I just have gone through in a overview. You can, yeah, you can just go to the like Decibels website, and there you can check out the powertrain related course. So you can just learn in a deeper way, like with a deep, having the deeper knowledge at the end. And you'll also do the proper battery sizing, and you also calculate regen energy at each sections, and what are the regen energy losses, and you'll study in the using MATLAB and Simulink. here we can just show like in the Excel. As the velocity increases, the battery power should be also more, right? Yeah, I just try to show the graph. Just check with your like equations, what you have used, and check with everything. Anyhow, like you will have this video in the YouTube, and again you can watch and try to redo the calculations. Okay.
Hey Krishna,
Yes, sir.
it's a great session. I think we pretty much taught everything that is as a part of the content that we intended to, right?
Yeah, up to the motor sizing, like we have covered.
Battery power also we have touch based.
Yeah.
Awesome. That looks great and a fantastic session in overall. I think we can showcase our website also, Krishna. If you have an access to internet, just open our site. Maybe just I can
Yeah.
also send an email later on to the participants if anybody is interested. You can go to the
Okay.
Powertrain.
Yeah. Just give me a minute, sir. Yeah.
Yeah,
Just.
sure. Right, Krishna. Right. I think yeah. Thanks a lot, everybody. It's a this has been a great interest for us to deliver the session so that we can all interact with you on motor sizing. And as I said, this is a very foundation session, where we were able to give you a very gist of component sizing and component approach of component sizing. I would not say this is all it is. There are a lot of in-depth, you know, studies that we have to do. This is a preliminary study, very preliminary study that you have to perform. But yeah, when you do it in MATLAB, I think we can go to homepage, Krishna. In the homepage, you can go to
Yeah.
yeah, yeah. So
Yeah. Yeah, we can see the powertrain sizing.
yeah, that course, and also if you go to the second next below and go to the EV, yeah, the section, the level 2 course, yeah. Go under the inside the course, Krishna, EV electric vehicle courses.
Oh.
Above first one.
Yeah.
All right. So cool. And if anybody is interested to learn about using model-based design and also using MATLAB and things like that, slightly below Krishna, we can go to level 2 courses. So we are sending you a coupon code, guys, who are participating in the course. The first course is the one which is electric vehicle powertrain modeling. That is the first program which has been listed there, where you would do a exact following same way as an industry follows. And you'll also learn MATLAB and Simulink. Those are the two major tools that has been used in the industry for modeling. And all these courses are done using similar software too. So where you'll be able to go in depth and model the systems, and also component sizing will be based on various different factors of influence. If you do a modeling in Excel, it will be quite complicated to implement all these scenarios and do a testing. So where you will be able to run the model for various different scenarios and test cases, where you'll be able to analyze a lot of details about our motors and its parameters. That when you go for a motor selection, so you would have all these parameters and upon which you will do a motor selection. Okay, so maybe if in a simplistic way, if you do an incorrect motor selection, it would consume more energy. That means the less range, because your battery would be consumed more for the exact range that you're expecting the vehicle to give you. Or maybe you're over using the motor's ability, and you may be ruining the motor's life if you do not size the motor properly. And in the overall way, it's all optimization end of the day, because everybody can build an electric vehicle. I think I can see in YouTube there are Tom, Dick, and Harry. They just buy some components from China or some other supplier, just assemble it and make it run. That is not an engineering basically, and that is done by everybody as in DIY stuff. But when you really want to develop an EV with so-called as an optimized energy consumption, it all boils down to a very minute of details
even to if you take an Ather, it's about 35 watt, average about 35 watt of energy it consumes per kilometer. Now, if you're able to design a vehicle which gives about like a 34 or 33, 32, if you consider over a lifespan of 75,000 kilometers, right? So what it has given as a warranty. So each kilometer you're saving about 3 watt, and for a 75,000 kilometers you are saving somewhere about like a 75 into 3. That's a huge amount of 75,000 into 3. That's a huge amount of kilowatt of energy that you can save. 75,000 into 3 is somewhere about 225, right? So 225 means 225 kilowatt of energy that you have been saved just by optimizing your components. So, I mean, it's very in depth to go. If you understand the value of 1 watt of energy, that's a very concluding factor as a part of it. So that's why there are simulation engineers. That's why we exist also in the market, that we do powertrain studies, that, if anybody want to develop a vehicle, it's not about like you just buy some components and assemble it. There is no point in doing a simulations even for that too. But if you really want to engineer a product which makes meaningful demonstration in the market, definitely you have to perform these studies, and that's kind of a roles available in the market too, for powertrain engineers to work on powertrain simulations and also another area of powertrain itself. So this course is a beginner course for anyone who is interested to begin their journey. And again, if you go a little below, we have in-depth courses on powertrain on level 3. And I would not suggest anyone, because that is a courses we offer for a lot of industry participants. Maybe quite in depth to understand if you're a student at this stage. But yeah, if you are very much interested, we can definitely help you in learning those courses too. But you could definitely start from the course. We will send you a coupon code from our team side. The mail will come to your inbox that you can avail in next 2 days if you're interested to learn and engage in powertrain simulations using MATLAB software. And yeah, that's in one concluding statement. And the second part is we will upload an assessment to our LMS. We will send you the instructions also, and you have to finish the assessment, and there will be one a quiz basically, and that quiz you have to answer by performing the calculations, and then whoever uh, uh, gets the good scores, and the automatically certificate get generated. We do not involve manually in any of those things. All you have to do is basically complete your assessment. If you complete your assessment, you'll automatically get the certificate, which are typically LinkedIn shareable, and you get a very unique URL for that you can use it to share to any of your job IDs and job profiles and stuff like that. So great. I believe you enjoyed the session. Not to spend any time in other areas, we directly jumped into delivering the content. I think it's about two hours nearly what Krishna has handled this session. I believe you enjoyed it, and I believe we always kept the decibels quality as we've been always doing it and promising it to any of our courses. So if any queries are there, you can always reach us out on our LMS portal. Where we have also the contact numbers where you'll be able to um, interact with us. So will you get a lifetime access once purchased? No, the lifetime access is not given. So it's limited access as mentioned in the website. Each course has some limited access, and yeah, so you could enroll in the course and get the duration of that. Right. So extension of the courses, you can connect to us personally or else drop an email to admin@decibels lab. We can discuss you about the extension. So if any extensions that has to be provided, there may be a nominal cost definitely for the extensions. So you can connect to us. You can drop an email to admin and or contact @decibels lab. So one of us will get back to you and help you further in terms of extending of the courses. If anybody is interested to learn, you can also reach us out on the same email IDs, or we can also drop you a number so where you can reach us out. If you're passionate to explore your career in EV, we're definitely there to guide you. And we help many engineers to also pursue their career and their passion. So if you're interested, definitely we're open to engage with you and help you in learning the things on EV. So I believe at the last you enjoyed the session, and thank you very much, Krishna, for delivering a fantastic session and keep it very interesting and exciting. Thanks a lot, everybody, for participating also in the session. We have uploaded the video lectures. We will upload the video lectures in the LMS. And also we have uploaded a NEDC drive cycle in our LMS. You can log into the LMS and you'll be able to download the NEDC profile. So you can practice, you can rewatch this video, also available on YouTube. Will be also available on our LMS. So thank you very much again, everyone, for participating in this session on weekend, and have a fantastic weekend ahead for you. And thank you very much, everyone. We'll also share your feedback kindly share the feedbacks to know how the session was. Thank you very much, everyone. Again, thank you very much, Krishna. Let's wind up the session for today. Thank you. Thank you very much, everyone.